Hi, welcome back to my channel. I just wanted to give you a very short introduction to the instrumentation and debugging facility that I just had a very short discussion on in my last video. So let us go back to the program that I was doing. Here we have the ADC channel code which we were checking out in my last video. So we need to see that what we are interested in this particular video. Now very in very usually and very often you would be facing the question that the tasks and the thread that has been created, so how are they executing in the real time. So this is where the instrumentation and analysis tool comes into picture. So what we have to do is, basically there are three things that we need to enable, but before that I would request you to please go to this particular user guide, to the instrumentation section, and you can go to the how error handling is being done, how debugging is done. So just go to this particular document. It's called the literature number SPRUEX3U. So with this particular number you should be able to download it. So please go through this particular document, and after that, or even you can also read after going through my video. So there are basically three things that I have summarized over here. The first thing is we have to enable the diagnostics, the logging, and the BIOS enabling feature of logging. Okay, so how do we do this? Basically I told you, see, that in our project explorer we have our application program or the project, as well as the TIRTOS kernel project. So in the kernel project you will have a folder called SRC, that is the source code. So in the SRC, usually the SRC will be with a cross sign, like it is not being built. So what you need to do is just right click on it, go to resource configurations, go to exclude from build, and there will be a tick mark over here. Just remove the tick mark. I repeat, remove the tick mark. So that will let you compile this particular configuration file for the modules when you're building the project, and just press on OK. So after you do it, you just double click on the release.cfg file. Release.cfg is nothing but a kernel configuration file for the modules that you will be using for your particular project from the RTOS. So here we need three particular modules. One is the diagnostic and configuration modules. So for that module, you just have to enable the runtime module, runtime.diax. So just copy this xdc.runtime.diax, go back to this particular .cfg file, press Ctrl F, paste it, and find it. So wherever you find, you will find this particular line like commented out like this. So just remove that comment. Okay, that's, you're done. Next will be the loading configuration. So you need to save the log files, the configuration and the running log files. So those kind of log files, like which will contain the information about how your threads has been run inside your core, that needs to be saved inside your target. So that feature has to be enabled. So that can be enabled by uncommenting this part of the code. So here also you will have to uncomment this line so that we can include the module for logging, and also some other settings, like you need to set up the UIA feature of the sysbios for logging. So also uncomment this line, and also uncomment these three lines. So that also I have summarized in this particular part of the text file. So if you want, I will put up the text file so that you can download it and have it in my video. So you can also download it from my GitHub repo. So here you also have to just let the system know that okay, fine, the total logger size will be 1024. Out of the main TIRTOS thread will be taking 512, and the load or the logger of the application that I'm interested in, or the thread, would be taking 256. So you have to uncomment all these four lines. And the last thing that you need to do is just enable the bios.logs enable feature. So just copy this line. Is this line by default should be existing in your .cfg file if you are using the latest version of the TIRTOS and SDK. Yeah, so just for these, after these four lines, the next thing is the BIOS logs enable feature. So basically the BIOS has this facility of logging, by saving the logs, but it is by default disabled because when you enable the logs, these logs will take up some amount of internal memory from your chip, from your target. So if you want these logs, by default they are not enabled, so you have to just select that line and find it out whether line exists. So here it is. Usually this line will be blocked and the false would be enabled. So what you have to do is just block the false line and enable the true line. Okay, so this is all you need to do to enable logging. So all these features are enabled right now. So I don't have to say, but you guys have to, after you do all these changes, just click on the close. When you click on the close, you have to save the configuration file. So after you save the configuration file, I'm just clicking on don't save because I already have it saved, but you have to just save it. So after just saving it, go back to your application, that is ADC single channel.c, and just download the code once again. After building, just recompile and rebuild the code and download it. So basically it will take some time to rebuild it if you're doing it for the first time, but since I have already rebuilt it once before, so it's not taking much of time. So now as before, we will connect the UART. So my UART exists for the XDS launchpad exists on COM3, but like if you're using a separate OS, maybe you might be having a separate COM port number, so please find it out. In case of Windows, you can find it out from the device manager, but if you're using other OS, please find it out by googling what COM port you're using, and whichever terminal program you're using, please go to and connect to that particular port. So it is already connected in my case. So what I will do, I will just go back to my application code, everything is ready. I will just resume or start the debugging session. Okay, so here you will see that my code has been executed. Now here I made a slight modification. What we were doing previously is for ADC 0, we were just recording a single value. We were just sampling the input only once. So that will create a problem when you see the execution analysis, because since ADC 0 function is only executing once, so it would take some nanoseconds of time, and the processor would either go to to the idle mode, and the BIOS scheduler will schedule the next thread, which is for the ADC 1. So I have increased the number of samplings for ADC 0 object as well. So now both the ADC 0 and ADC 1 are sampling the inputs P59 and P60 12 times and giving me the output, the converted results, 12 times. So that is why you can see starting of the example is here, and ADC 0 also gives me total number of 12 values, and the same for ADC 1. So you can just go through the log, your console log, you will understand yourself what is going on. So what we would be interested in, like the code has halted, it has executed both the functions, and it has finished off its task that we had given. So now what we will do, we will suspend the session by pressing in this button, or you can also press Alt plus F8. So when you suspend the session, the next thing you need to do is first go to Tools, follow it very carefully, go to Tools, then Runtime Object View. When you click on the Runtime Object View, it will ask you to connect the debugger to your target for the existing or the program currently being debugged, which is my ADC single channel code. It's yes, so I will say connect. So it's connecting to the code, it's connecting to the target core. And once you are connected, what you will see is you will have a nice overview of what's going on inside. See, the idle task has taken only 240 bytes of memory, so there is no stack overflow. If you have a stack overflow, this red color will appear over here. Also, your ISR stack, which contains all the details about the thread 0 function, thread 1 function, that has also not overflown. We have only used 440 bytes. So if you are having any stack overflow problem, definitely you will be able to see it here. So this is a big thing for us application programmers who are doing it on RTOS, wherein we might land up with some stack overflow problem. So that is not there. Also, the next important thing is, like, we would like to see the execution graph, like how the task functions or the threads were executed. So what we will do is, again go back to Tools. I repeat, again go back to Tools, go back to RTOS Analyzer, go to execution analysis. When you select execution analysis, a window will come up asking you that okay fine, which execution analysis you want to do. Now right now we are interested in the execution graph, which will show me how the thread functions has scheduled itself. So I'll keep that checked, the status is good. So now I'll just say start populating the curve. So here once that curve is populated, we can see it's already done here. So once your graph, execution graph arises, this is basically nothing but your idle bias scheduler and the thread functions versus the time curve, like which part of the code has taken how much amount of execution time, to be very simple for the beginners. So what you do is you can just see a small plus sign. You have if there is only one code, like we have only one code here, you will have this code. Otherwise, you will see your own core. If there are two cores will come here. So what we will do, we will expand the code. Once we expand the code, the thread code, here you can see the bias scheduler, the idle function. So the idle function is taking the most amount of time. If you want to see how much time it is taking, just left click on it, a red line will appear, so you can drag it and have the value at the bottom, so that you can calculate how much amount of time it has taken. Also, if I zoom in a bit, zoom in is done with the button of control and equals. So if you press control and as well as the equals button, you can zoom in, or you can directly press over here. So here you can see the idle task is running, and then after that the thread 0 function is being posted. Okay, so that is being posted over here, and it is running for a very small amount of time. And then the processor is going back to the bias scheduler. I should zoom it a bit more. It is going back to the bias scheduler. So the bias scheduler, what it does now is it will say okay fine, my thread 0 function has done its own part of the task. Now it posts thread function 1. All this is happening inside my task main thread that I have created. So now it posts this function thread function 1, which reads from ADC 1, and that goes on for a sufficient amount of time. Okay, and then it again goes back to bias scheduler, and then the processor goes to idle mode, because these particular tasks will take their own time to read from the ADC while the ADC converts and then presents with the value. Till then the processor has no work, so the processor goes back to the idle state. Now when in the idle state and all the data is ready, I'll just zoom out, all the data is ready. So then again the processor, it goes to, here you can see, I will just zoom in a bit, here you can see it goes back to thread function 1, and then after that it gets posted back to thread function 0. So this is how we have the execution, and you can just reset the zoom and see how the execution is happening. It's like very interesting how the execution is happening. It's where I leave this to you as an exercise to make some make some alterations in the thread functions. For say thread function 0, change it. Right now it is 12 for both the cases. You can change it to for one you can make it to 6, and the other you can keep it 12, and see how changing time affects the this particular execution analysis curve. So I think this is a very pretty interesting part that should have been discussed, and that I left blank maybe in my last video. So this is quite interesting for beginners as well as for experienced people. And right now we are not doing much of a thing with this part, but don't worry, with the later videos where we will be dealing with semaphores and mutexes, we have to go and look into this execution analysis curve and see that how things are going on, or if you face any kind of problem, troubleshooting will start from here. So that's all of you, that's all for you right now. I hope that it was a good session for you. It was very small, but I wanted to keep it small because it shouldn't be boring for you. And do let me know in the comment section how was it. If you like my videos, please do like and subscribe it, and please do comment and let me know if I need to change anything, if what I'm saying is good for you, if I need to add on anything. I will definitely try to take your views into my account. So thanks, stay safe, stay healthy, and see you in the next video. Thank you.